Welcome you all to the Digital and Computer Organization BCS302, the laboratory sessions. Myself, Rasika Amring, Assistant Professor at ATMEC Cyber Security Department. So today's experiment we are discussing about design a Verilog program to implement the different types of multiplexers like 2:1, 4:1 and 8:1. So the experiment 6 talks about designing a Verilog program. That means write a Verilog program. There could be three ways. One is data flow, behavioral or structural. So in any of the three ways, design a program to implement different types of multiplexes. So whenever it comes to multiplexes, it talks about n number of inputs and one output. So that n number of inputs could be 2, 4, 8, likewise. So here is 2:1 multiplexer. This is the logical representation of multiplexer, wherein with this a number of inputs, the output that is selected will be with the help of the select line. So in n number of inputs that we have, the select lines will help to decide the input that is to be provided in order to obtain the output. So this is the combinational circuits which are built in order to obey the logic with respect to inputs, n inputs and one output. So that is what it says, 2:1. Likewise 4:1. Likewise 8:1. This represents that four number of input variables are used and one output will be obtained. 8 input lines are being provided and one output is expected. Among these four, which one is sent as an input is decided with the help of the select lines. Even in 4 and 8, the select lines will vary when the number of inputs are also increasing likewise. So this is the data flow description, wherein end module and module are the two keywords we use. MUX 2:1 is the name given. Input select line. Input I1, I0 and I1 are the input number of inputs and the output Y. So when we are assigning the logic Y, it is using the ternary operator to provide the condition, that is if the condition is true, that is select line will be on if I1 input line is selected, or if the select line is 0, then I0 input will be selected and output will be obtained likewise. And the truth table also mentions exactly the way. If the select line is 0, I0 output will be obtained. If the select line is 1, I1 output could be obtained. This you can see with the help of the ISC project test suite, wherein the implementation is being done with respect to 2:1. As mentioned earlier, the inputs are provided, the select line is obtained, and the output that is being chosen is also mentioned here. Assigning the output with respect to the ternary operator to justify the condition wherein the select line will be 1 if the input is B, otherwise the select line will be 0 in the case of A. So when we go for the simulation and perform the simulation of this, the output obtained will be of this format. So if you could see the select lines, if it is 1, then B input is also 1 and Y will be obtained. Else if all are 0, then the output will be 0 likewise. With changing these inputs, you could see the select line is 0 and B will also be 0 as per the logic, and when A is 1, the output will remain. Output will be obtained, but which output is obtained with respect to which input is decided with the help of the select lines. So if the output is B, then the select line will be 1. If the output is A, then the select line will be 0. So this is the representation of multiplexer 2:1 multiplexer. Accordingly 4:1 and 8:1 is also being carried out. So this is about 2:1 multiplexer. Thank you.